pleasure for me to welcome Dr. Tom George for this today's evening talk on the very important topic on solar energy.
No, it's normal. Okay.
And I would like to introduce him briefly. And more important, what I want to tell is that he has years of experience. Therefore, some of our students can think of associating with him even after the talk. And I would also participate. And we can do a very useful project, 1 or 2 projects on solar energy harvesting. Basically, Dr. Tom George is a senior member of the technical staff of the Schneider Aveva, UK technology company, headquartered inside the Oxford University campus. So in the UK, their headquarters are there, and Aveva. Earlier it was Schneider, and Aveva is one of the subunits of the company. He is a highly experienced technical member with PMI certification in software engineering and project management and quality management. And he has 22 years of experience in various capacities, including customer experience management. And he has worked with multinationals such as Ratum Tech, Invensys, Schneider Electric, etc. So he has almost engaged with and worked with many customers almost across major economics globally since the year 1999. He was earlier, before going into technology, a research scientist working for a Singapore company developing cryopreservation protocols for long-term storage of non-mammalian gametes. It really shows that he has a broad interest both in science and technology, and he is currently focusing his efforts and interest in the field of solar energy harvesting. And I'm also wishing very eagerly, waiting eagerly to hear to him and see whether any kind of synergy can happen between Schneider himself and R&S Institute of Technology. Thank you, Dr. Tom George, for kindly agreeing to give the talk. Without standing in between you and the audience, I request you to start your presentations.
Thank you very much, Dr. Dinesh Anvekar. And before I just go into this, the organizers, one of my colleagues who is kind of my collaborator wants to join, and he joined somebody, removed him. If he can join again, that will be great. His name is Sahadevan. He'll be joining soon. So those who are proctoring this thing maybe can allow him.
Yes,
That will be great.
Yes, sir. You can join.
Him to join again. Yeah, so that's nice of you. Thank you very much. So good evening and welcome to everybody to this talk this evening. And I know a large number of students and staff have joined from R&S SIT College. In the very outset, let me thank the college this evening with a very interesting topic, that is solar power and rooftop power plants. So the other day when Doctor called me, I was surprised that he was very, very eager to give the students a kind of insight what is happening in the solar world, so that some of them can, in the future, in the near future, take it up as a project and, of course, graduate into solar energy and related topics. So with that note, let me just start. Again, the title is Solar Energy Harvesting, and with reference to rooftop power plants. So I'll be touching upon solar power briefly, and I know you're all electrical and communication and electronics engineers, so you all will understand. Maybe I will touch upon certain things just peripherally, because you all can go ahead and read more about that, because this is a very subject that you are learning in the college. But I'll be giving kind of touch to my practical experience with solar power harvesting. So that's about me. If anything is, if you want to ask any question in between, you may interrupt me and ask. And if there is any problem with the visuals or the mobile or the audio, let me know.
It's clear, sir. You can go ahead.
Yeah. So a few words about my profession. I'm a software professional, and my original background is biotech. I did my PhD and MTech from IIT Kharagpur. And why I'm connecting all these, I'll let you know how I accidentally got into solar power. Apart from the scientific curiosity, there were a few real life situations that triggered my interest in solar power. I'll just briefly mention that because it has got a connection with my life and probably with your lives as well. Few months ago, my father passed away, and he was bedridden for a whole 1 year before that during the entire pandemic time. So since he was bedridden, he had to lie on his back, and there's a possibility of getting blood sores. So doctor suggested that he may lie on a recent development called air bed, which requires a small air pump to work continuously day and night. It is in such a way that the air will leak out of that because air get warmed up, and the compressor, which is around 25, 30 watts power, needs to work continuously. In my place, if there's a power interruption due to some cyclone or rain or any other thing, the power company may not come immediately, and they may take 1 or 2 days time. Hello, am I audible?
Yes, sir.
Yeah, somebody interrupted. That's why I just listened to it. Yeah. So it was a necessity, and it was in the peak of pandemic. It was lockdown. So there's no way that I can go from Bangalore to my hometown, that is Thrissur in Kerala state, and get it done, what is necessary. So I decided that to make the inverter at home, which works only for 3 hours maximum based on the normal consumption, to make it continuous and 24 hours or even 48 hours continuously working, the only way for me to go is solar. So that was the main reason I started looking into solar power as a life-saving device for anybody who is bedridden or a power interruption will interrupt your life. Secondly, back in Bangalore at my home, I also had, we are all working from home, studying from home, online classes. We can't afford, especially a webinar like this, during a webinar like this, we can't afford the modem to restart, the laptop, this session to be interrupted because of internet connection is gone, because the modem was interrupted, and rejoining is not an option because my family, all are using this connection. So for me as well as yeah, there was an interruption. Am I audible again?
Yes, sir. Yes, sir.
So I had this curiosity of using solar power for a domestic purpose or any other purpose long ago. I'll show my experimentation towards the end. I inquired, long back when I made this house 8 years ago, it was very, very expensive. And I dropped that idea at that time, and I was waiting for an opportune time so that I can have an affordable solar power system at home. Moving on, I have a small issue here. It's not. Yeah. And apart from that, being in technology and a scientist in nature and by profession, I always wanted to go green. The go green aspect is very important. I don't need to repeat it because the world is suffering a lot. Climate change, sea water level increase, temperature rising, and all those things we are all very familiar. And it is going to have a profound effect on our lives. We are already seeing it. A lot of natural calamities are happening because of heating up. The temperature of our climate is heating up. And because of that, glaciers, ice cap, everything is now being depleted. So if I can't do something on my own, at my home level, at my personal life level, to stop this thing, what am I expecting from others? So that was bothering me all the time. So when a time came that I need to do something about it, I just acted, even though I had to spend a lot of money on that, but I was determined to act. Moving on, I don't need to tell just from my experiment, I mean, my experience, I need to tell from the global perspective and also from the government perspective. You must be knowing that the government has announced a few years ago that by 2022, India will have 175 gigawatts of renewable power, whether solar or by wind power or any other means. But Corona, a pandemic, etc., we could not reach. We just itself is a big achievement, but it's not enough. We are falling short. So there is a significant shortfall to meet the promised target. Because of that thing, the government itself has launched a lot of programs to give incentives to power companies, and they themselves are incentivizing people to have their own arrangements at home so that they can install solar rooftop power plants on their roofs if they have access to their roof. So that's the background of solar rooftop power, what do you call, explosion in India in recent years. Moving forward, you might have heard about solar rooftop incentives from the BESCOM and the state electricity boards and other DISCOMs. If you generate your own power by using a solar rooftop power system, power plant, and sell to them, they will pay actually to you. They will cancel or they will compensate what you have already consumed from your meter. I'll come to that practical aspects a little later. And the balance, if you have exported more to the grid and you have consumed only less than that, the positive difference they will calculate and they will pay you an amount, corresponding amount to you. It will be adjusted in your bill. All of you must be knowing by this time. So when such a program is there, it's up to us to avail to go green. So that's the point I'm driving home here. So coming back to a little tricky point, the rebel in me, the rebel in you, will always fight with the local supplier when there is a power interruption. Mind you, we are already paying a part of our bill for the infrastructure they have created to give us power. That means we are paying 10% of that amount. I'm paying close to 400 rupees per month and extended from their powerhouse to my home. So they have a responsibility, like developed countries, to give me uninterrupted high quality power, but it doesn't happen. So people have decided by going solar that generate your own power. It's a big philosophy. which will also offset your carbon print. You have the bragging right to tell that I have no or practically least carbon footprint on this planet. I'm generating my own power, I'm consuming it, and I am helping the state electricity board as well during their peak hours. So that's the concept of generate your own power. And you can sell it too. And the current rate is kind of 3 rupees per unit, that is kilowatt hour, if you sell it back to them. So the DISCOM means electricity distribution companies. So when they want, when you have extra power, when they have a peak time or falling short of it, you can sell it to them. It will happen automatically. I'll explain it further moving forward. So coming back to the solar power proper, solar power is the power from sun. You see, in a way, all power we consume on Earth is indirectly or directly from the sun, whether it is wind power or hydel power or solar power or even fossil fuel power. Burning fossil fuels itself is a kind of a canned solar power, which happened millions of years ago. So I'll just bring your attention to just a few kinds of solar power trapping methodology. As you know, one is solar power. That's the left, this thing. And we have solar water heater, different kinds of solar water heaters, which will, in a highly efficient manner, trap the sun's heat energy by absorbing infrared from the spectrum and heat the water. And that is the solar water heater. And there is one more very expensive but green way of trapping sun's energy. It's called molten solar water power. It is in an open field. There will be a lot of solar reflectors, distributed those reflectors, which will focus sun's, they're called heliostats because it will track the sun and point the sun's energy as a dish antenna towards one point where solid salts will be molten at a very high temperature. It can even attain 1500 degree Fahrenheit. So the molten salt can be stored in an insulated tank, and that heat can be used to make steam, and the rest is generating heat. Rotating a turbine and generating power from that thing. So these are the major 3 approaches for trapping solar power for human purpose. And the proper term for solar power for energy is called solar photovoltaic, in short, PV. And this is the most widely adopted method for harvesting solar energy today. And the solar, coming back to the solar power proper, it is generated almost every time, always by using a solar panel, which can be a small one, as few centimeters squares, because if you need for some application, if you need only few watts, it can be a small one, or it's a huge size like that we have on solar panels of satellites, International Space Station. And back to Earth, these solar panels have kind of different applications and different sizes, different types, and different value, different power, different voltage, and a lot of things based on the applications. I'll come back to the electronics of solar cells. A solar panel is made up of a lot of solar cells, smaller the basic structure called the solar cell, and it is all laid on a kind of a matrix form, and it is interconnected. When you talk about solar cells, there are different kinds. I don't want to go to the history because solar cells have a very long history, but the public started hearing about only in the last 1 or 2 decades when it started used for industrial and domestic purposes. The two divisions are, one is monocrystalline and the other one is polycrystalline. These are all silicon cells. I'll go to the details of that. You must be knowing, you all know as the engineering students, P-type and N-type silicon, which are used in semiconductors with a transistor or diodes or in microprocessor fabrication. So the same very silicon cell crystals are used making solar cells. If I can oversimplify it, you all can read it up later on. But a simplified model of a solar cell will be two cells, one N-type, one P-type, are stacked one on another. And while fabricating, there will be, what is a depletion layer, and there will be, because of the doping and other processing, these two structures will be fused, and there will be intervening layer called depletion layer. And because of these chemical reactions between them, it will be stabilized to have a layer which is electrically neutral and in equilibrium. So when it is fabricated and made as a solar panel, and when light passes through it, that means when solar insolation, solar power, solar light, sun's light rays go into that thing, this depletion layer will lose electrons. And because of this, the electron, that is the moving electrons, will be trapped by the holes, thereby neutralizing it there itself. That's a kind of power loss. Otherwise, if it is properly connected, properly oriented, all parameters fine, this electron will flow through an external circuit. So that's called electric supply to an external source, to a load. It's up to us how to use it. So I'll explain more how it is done. This simplified picture tells it all. You can see the P layer and the N-type layer, and intervening PN junction, which is nothing but a depletion region. And in solar panel, you have on top of this structure, there's a glass, which is kind of an anti-reflective coating, because it has to absorb the maximum amount of light. And technically speaking, all these are kind of power cells or batteries, and they are connected in series and in parallel based on the voltage level that we want to generate. This is, mind you, this is a kind of oversimplified diagram to make you understand how it works. This is an actual solar cell. The left one is called polycrystalline, which is kind of becoming old because of various reasons, which I'll come to. The right side is monocrystalline. The monocrystalline type is grown from a ingot that is made in nature, which is expensive. That's why monocrystalline solar panels are more expensive than polycrystalline. And mono is also preferred nowadays because it is slightly more sensitive to light, and its power its power generation is more. So the more means it is expensive. The lesser parameters means it is cheaper. So polycrystalline is cheaper, while monocrystalline is expensive. And the world is now preferring monocrystalline because it can give you higher power because it is sensitive in the morning itself. I'm using it here. Mine is mono PERC. I'll explain those types soon. So since it is highly sensitive, at sunrise itself, it will start producing power, while the polycrystalline panel, which is cheaper, of course, easier to get, of course, will be still sleeping maybe for half an hour more. So at 7 a.m., when it starts producing power, after waking up, this guy, monocrystalline panel, has already produced power. Not very high, but sometimes enough for some basic function. So that's the difference between mono and a polycrystalline. And moreover, the latest in monocrystalline technology is PERC. It's called passivated emitter rare contact cell. I'll explain in your terms. It's a common term in metallurgy and of course in semiconductor fabrication. There's a process called passivation. Passivation layer is behind the N-type or P-type, whichever type they choose to. It's a kind of a reflective surface, not like mirror, but kind of passivated or a kind of opaque, so that the photons falling on the surface will get one more chance to get reflected and one more chance for the trapped photon to get reflected back into the trap and generate electricity. So this is called the PERC. So the most advanced, one of the most advanced type of crystal or I mean cell is mono PERC. So it is expensive as well. But a lot of projects are nowadays preferring only mono PERC based solar panels. Moving on, how a solar panel is constructed. This is again a simplified diagram. The top one is an aluminum frame because the whole thing has to withstand the powers of nature. It should not break off. It should not fall off. It should be not even bending. So for giving a structural integrity, an aluminum frame is given, and inside it all the layers, a tempered glass, so that this silicon structure surface is not exposed to the elements, and water will not short the leads. And below the tempered glass and between the lower layers, there's an encapsulated kind of a silicone gel kind of thing, not the silicone gel kind of material to make it waterproof and electrically proof between the cells. So this encapsulant upside on its below will take care of sealing it, and in between all is the solar cells on a matrix. And of course, at the rear end, at the last layer is a backsheet. It's a kind of PVC or some other polymer kind of strong but thin backsheet. And behind this backsheet, there is a junction box wherein the final leads are coming where we can take the power out. So when all these things are structured, a modern solar panel, a mono PERC, will be generally kind of a 6 feet and 2 feet in wide, 6 feet tall and 2 feet, in wide. And the weight could be based on the brand, and the power output could be a kind of, it is a kind of a 20 kilos. Now I'll move on to various types of, this is the crux of solar power plants. The heart of a solar power plant is the, of course, the collector, that is the sun-facing solar cell, I mean solar panel. And you can, based on your budget, the space available, or the project incentives, or project goals or objectives, you can go for any one of these. The most commonly used, as I said earlier days, is polycrystalline. You can see this is a polycrystalline, and you can see also this is a PERC, passivated emission rare cell contact. So this now gave way to the mono PERC. This is the most widely used solar panel nowadays, and there is a difference in efficiency percentage as well. Poly PERC 16 to 17, and mono PERC is 17 to 19%. 2 or 3% improvement or increase in the efficiency also will lead to a huge change in huge megawatt level, utility level projects. So that's why that 2% is also very important. Moving on, if you can see on the rightmost top row, there's something called half-cut mono PERC. This is the latest trend in solar panel production, because explaining that when there is a shadow falling upon, even if it is for some time, on a solar panel, its efficiency, its production just drastically falls down to sometimes to below 50% or 30%. Because when there is an intervention of a dark shadow in between the cells, these are all like batteries in series. So when one battery is down, there is an effect on the overall power flow. So to avoid that, what they have done is a simple logic. They have divided the the solar panel into two regions, which are acting actually. So on the tip or on the bottom side, even if there's a kind of trees, leaves falling or something sitting on it, something falling on it, some animals coming on it, or even a shadow cast by the sun in the morning from an adjoining tree, will affect only one half of it. So if the panel is of 400 watts, it will not go below 100. In fact, it will produce 200 watts. So that's a big saving, especially for domestic solar panels. So similarly, you can see here half-cut monopore. It's another extension of the same logic. It is this kind of dual, is called dual, two regions in one solar panel. This one, what they have done is they have reduced the size of a full-fledged traditional solar panel, which are kind of 5 by 6 inches, into half, so that some ohmic loss can be reduced. When you have a longer piece of a conductor, in this case a semiconductor, the properties change, and its internal resistance comes into a picture. So this is dual as well as cut cell. The cells are half, which again gives an advantage of a higher percentage, and you see it goes up to 20.5%. So essentially, these are all combinations of mono, PERG, poly, and mono and dual. And not mentioned here, which I'll show you a little later, is one more type, which is a kind of ingenious idea called two-sided. Okay, these are all you might have seen in physically or in photographs. Only the solar cells are always looking up. So what if you put the trapping layer or additional solar cells on the bottom, so much so that it can even trap the photons coming from the sides, reflected or radiated light, or the ambient light. So of course, unless it gives direct sunlight, it cannot give you much power, but a 10% increase or 20% increase during the noon time from the stray light can also give you additional power. So the efficiency will go up. So such panels are called bifacial. I'll show you how I used in at my home. So mono, crystalline, and dual, and cut cell, and bifacial. These are the latest rage in solar power generation. Moving on, these are all from outside India. Some of these are available in India as well. The branch of solar panels. Panasonic is available in here, and we have our own made in India like Vari. We have a Kirloskar, and we have Loom Solar. We have Luminous. We have a UTL and a lot of other brands. But mind you, these are all assembled solar panels, or called modules. The solar cell is invariably imported, because fabricating solar cell is a big business. You need huge investments for a fab. You need a lot of cheap power, cheap labor to make it cheaper. Incidentally, I just would like to tell you that I was very, very fortunate enough to see and go inside a fab when I was studying in IIT Kharagpur. We had a small fab, which is very rare in India. Even now, there aren't enough fabs. A lot of people did never get or may not get a chance to wear PPE kits. Nowadays, we are using it like that. We need to be, it's a clean room. You must be knowing a small dust or your hair or any dead cell falling off from your skin can be bigger than a transistor there on that in terms of its role. So I could sneak into that with the help of a professor there. I went there. I have seen this is amazing. A fab is amazing. So it is power intensive and labor intensive and it is costly. That's why India is still lagging behind in producing solar cells. However, we are importing from Germany and other European countries, and mainly it's a stronghold of China and all. So we import and we lay it and we assemble it and make it as a panel. So that's a business side of a solar panel. So this is just for your information. See, the efficiency is varying between 20 to 22.6, etc. So there is not enough a variation, but there could be variation in its price and availability. So now I'll move into the practical aspects of solar power plant, especially a rooftop power plant. You see, now you have a solar panel. So how to fix this on your rooftop? So that's this is just a one single slide on the rooftop. I'm not going into the details. It is a marriage between electronics and computer science and here mechanical engineering. A mechanical engineer or a fabricator comes into picture when they design the structures and they sell it. So you don't need to be a mechanical engineer. You can just buy ready-made solar rooftop mounting structures and easily mount it. This shows how a panel is mounted on top of your roof. Going to the details, I just wanted to show you how you can sell power back to the DISCOM. This is a simplified picture again. Here it is shown, this is the solar panel. The power generated when there is sun, when there is insolation, when there is sunlight, power comes to this thing and it goes to the inverter. Inverter is actually a kind of, you can say, another heart of the top power system. So the inverter converts, as you know, the DC coming from the solar panel, the low voltage DC, but high current, converts that from DC to AC. Inversion, that's the, by definition, inverting. So this power goes to your home and you consume it during daytime. And if you happen to produce more power, there's a unique meter called a net meter. It's a kind of meter which will meter how much you consumed when you were the consumer and how much it exported to the grid. Grid means the electricity board network, power network. So the electricity board will settle your bill at the end of the year. In Kerala, you know, it's in September. The whole year's your consumption versus their consumption from you. That is how much you exported. And based on that thing, if you have given them 100 100 units, one is 1 kilowatt hour. 1,000 watts continuously used in an hour is 1 unit, 1 kilowatt hour. So they will pay you kind of 3 rupees. That's the normal power, power purchase rates as per the energy markets. It can vary. So this picture shows that you can produce, you can consume, and you can also sell. And at your will, at night, when there is no sun, and when there is a rain, or when there is, as I said, the shadow is the enemy of power generation in solar power. So when there is shadowing, even it could be cloud. On a cloudy day, you have only diffused power. The monoPERC dual bifacial will still produce power, but not its actual full throttle power generation. So at your will, you can consume picture how net metering works. Moving forward. This is a simple 2 kilowatt solar rooftop power plant. This is not me standing there, this is somebody else. You see, this is an old structure, and this is a 2 kilowatt power plant. Each one is 250 watts, and you have 8 of them. So combined, the installed power capacity is 2 kilowatts, and almost never you will get that 2 kilowatts because the 2 kilowatt is rated for this solar power based on an ideal condition in the lab, because this is solution when they tested and rated and certified this. It should be at a 25 degrees Celsius at 1,000 watts of flux, I mean light flux on falling on it, 1,000 per square meter. So that's the parameter for a like a standard temperature and pressure. So in production situation, you will never get it. But if you are lucky, if you have no shadowing, and if you are in a place where it is not overcast, that means less shadow or less your what you call overcasting because of this clouds, you will get close to it, maybe a maximum 80% of it, because you will have a lot of loss in the cable itself. You must be knowing there is something called a DC cable which is used for solar power. You cannot use normal AC power because of the skin effect. You must be knowing when the frequency of the power or the signal increases, the power actually will tend to move towards its skin. That's a skin effect. So if you give AC cable, it won't work here. It will work, but you'll have loss. So you need to have a solid core, if possible, multi-core thin cable, DC cable, which is running from this junction box to your inverter. So that's why the way in electronics communication, you use the coaxial cable connection close to the antenna and close to your front end equipment, very close, the lesser the better. So the same way, DC cable also should be very close to the inverter so that the loss is less. So that's why I was telling, with the loss, invariably you cannot avoid that. You could get 80% of this installed capacity as usable. That too, in the noon time when sun is above your head, that means the angle of incidence is normal to the surface, and you have kept the angle so accurate that sun ray will fall at the noon time normal to it, because Earth is tilted on its axis 23.5 degrees. So you need to compensate by tilting the solar panel towards south. So that's ideal. But there are variations also that you need not do it all the time. There's a design parameter when you want the peak, whether in the morning or in the noon time or later that. So moving forward, as I said, this is a typical kind of net, on grid, be connected to the grid. It's a kind of what you call maybe 5 kilowatts inverter. So this inverter is used when you are connected to the grid. The next to it will be the net meter. I'll just show you. Now I'm kind of coming to the practical aspects of solar power plant. This is, I just wanted to show an off-grid domestic kind of 1 kilowatt inverter, which I'm using at home here. So my philosophy is that most of the households in India, where you have 3 or 4 people or 5 people, will need only 1 kilowatt. That is actually sufficient for most of your power security purpose. So I can explain if you want to know more about this thing towards the end. Moving forward, it's called, I said the DC cable. Take a look at it. It has to be, the core has to be very thick and it is expensive. So anything other than the solar panel is called balance of the system. So the cable is, it adds to the cost, and it's called a balance of the system. The cable, the connectors, and various other things like the distribution box, the breaker, circuit breaker, etc., etc. I just want to show a higher power for on-grid. Sorry, actually this is an off-grid. It's my mistake. It's an off-grid domestic 5 kilowatt inverter, where people would like to connect their heavy loads like an AC. So 1 kilowatt, as I said, is not meant for an AC to be connected. It is only for just all your fans, all your lights, or maybe your TV and even fridge. So incidentally, I just want to tell you that why it is a 1 kilowatt. I have taken a power audit of my home, and I've seen that all my power, barring the washing machine and iron box and other heavy stuff, all other normal loads, they don't add up to 1 kilowatt, because nowadays we have LED lighting. We have a 5 or 4 star fridge. My fridge consumes sometimes only 50 watts, sometimes only 100 watts. Similarly, even my washing machine is these are all called inverting gadgets. I mean, inverting appliances. And recently, we also have in the market the BLDC, brushless DC fans, which are very, very power efficient. The normal fans, they consume 75 to 80 watts when you turn the regulator to 5 or the highest. In this case, BLDC fans, ceiling fans, consume only 25 watts. So it is just a clean 1/3 of it. Similarly, washing machines, my washing machine is an inverting one. The term is inverting because it inverts the technology. I'll just briefly mention that it takes the AC power, converts into DC, and manipulates, variable frequency drives. With that technology, it drives the compressor or it drives the motor so that we have a control over it. There is additional board which will control the speed required based on the temperature that we have set for AC or the fan speed. So it has greater control over the motor, and the motor, the powering this movement is not an induction motor. It's a kind of a brushless DC magnetic motor. So coming back, so the power efficiency of domestic appliances have gone so much that you can do a lot just with the 1 kilowatt of power inverter. So that's what I want to just drive the power. So drive the idea here. When it is 1 kilowatt inverter and your requirement is most of the time is only 1 kilowatt, you need only 2 or 3 solar panels. So the cost of the whole system has come down. So that's why I just want to tell that it is affordable nowadays, because in the last few years, the components power cost has fallen down so much so that it is not in lakhs anymore. That's why when I started in the current house where I'm staying, I wanted to have a power plant, but they said 3 lakhs, 4 lakhs. So I said, forget it. So now with just kind of a 70,000 rupees, I can designed and created and used, commissioned my own power plant. I'll show you that. I'll show you. So one important part of solar rooftop power plant is where you, if it is an off-grid one, where you store your power, DC power, when you have a production in your solar panels. So the DC comes from the solar panel, it goes to the inverter, and it is stored in your specific storage batteries called tubular, tall, what you call solar power optimized lead acid batteries. Because lead acid batteries are still, it is a 100-year-old invention, but it is still ruling the roost because it is powerful as well as affordable for common man. The one I'm showing here is optimized for a solar use, because solar power is not an assured flow. Sometimes due to shadowing or clouds, the power availability will be just a few 5 ampere or 10 ampere. Sometimes the amperage will go up. So this is so designed that it will still get charged even at lower amperages. Another part of, as I said, there are different components in balance of system is connector, because you cannot just connect it to by splicing, because there is high current in it. So if there's a loose connection, it will spark off and the connection will go, and it can even lead to fire. So the ideal way of connecting to DC cables, which is detachable easily, is world standard called MC4 connectors. It will just snap in place and you can just take it out. Yet the connection is permanent. Now I just wanted to, I know I've taken up a lot of time. Sorry for that. I'll just move on to show my setup here. If you can see this, you will be wondering why this is unconventionally placed on a vertical plane. Okay, this is called vertical mounting. In my understanding, for rooftop experimental stations, nobody has done in India, as per my understanding. I've not seen in the literature. I just put it this way. For some reason, I was experimenting a lot. I'll show you. I'll come back here. I didn't mount it. The tube is my water solar power solar heater. I just mounted it, just put it using a stool on different directions. I started doing experimentation. What is the effect on the power generation, what is the orientation, the temperature, and the insolation, and when there is no direct light. So I studied all those things, and in one stage, I just mounted it because it was a little costlier. I just wanted to do when I needed it maximum. So these are the experiments I did last year. That's why loose wires are there, you can see with the connector. And finally, I mounted a bifacial. The earlier picture was from the other side. This picture shows the other side of this. So both are identical, wherein you have the solar cells on the sunny side and on the lower side. Moving forward, this one is my other three. See, there is one bifacial here as well. That's I wanted to show the back side. And on the left side, you can see the traditional single-sided, and the white surface you can see there on is the back sheet. And the black box here is the junction box where you can evacuate the power to your for your use. This is the full setup of my mounted one on the horizontal plane. And the wires are still hanging loose because I do occasionally still a lot of experiments by disconnecting the monofacial to see the production from the bifacial, and different variations I used to do to study the various parameters. And this one I made it at my home, I mean hometown in my parents' place. This is also bifacial. There are 3 panels, and it is mounted high so that there won't be any shadow cast on it from the nearby trees. This was my last slide, and sorry I have taken a lot of time, and I'm ready to take your questions. And sorry if I moved a lot faster. That's how I could come and consume all this time for a meaningful explanation that what I knew about solar power. And back to you, sir, and we can open up for Q&A session right now.
Yes. Participants can ask any question, queries.
You can type.
Hello. Hello.
Hello.
Yeah, please go ahead.
Can you hear my voice, sir?
Yeah, it's loud and clear.
Yes, sir. Thank you for wonderful talk, sir. I am from chemistry department, RNSIT. So I want to know what will be the cost. Suppose if I want to install 1 kilowatt at this moment. So what will be the total cost?
Yeah, that's an interesting question. I should have mentioned it in the body of the webinar. I will tell you. It varies from brand to brand. I'll just give you approximate price. The panel that I have used here, the 2 panels are mono-PERC, single-sided. It came at that time for 12,000 rupees, 1 panel. But mind you, That was the latest at that time. I ordered during last September, and it was 12,000. It's peak power. Okay, its maximum power is 375 watts. When you compare the power of solar panels 10 years ago, this is a huge jump. So just with the one panel, you are getting 375 watts. So that is 12,000. Now, latest models have come. So the power has, I mean, the charge has come down. So you can get the same thing kind of for 10,000. So if you want to make it a 1 kilowatt power, you need to have actually minimum 3 of it. Okay. And the
Okay.
other side is the inverter. Inverter will be kind of 1 kilowatt inverter will cost you. Solar power inverter is different from the normal one. Normal one is very, very cheap. This one will be kind of 9,000 rupees for an inverter. And if you are making an off-grid, 1 kilowatt, you cannot make an on-grid. It has to be off-grid because Bescoms, they want 2 or 3 minimum kilowatts. So you need 1 or 2 batteries based on the backup time that you want. Okay, at the highest power in that grade is in lead acid battery is 200 Ah. That will be kind of 16 to 17,000 minimum for a 200 Ah, which is enough for a. So when you add up this 10K for inverter, it's kind of 32,000 for 3 panels, and your battery for a 16 or a 17, and some cables
Oh,
and a few other accessories. So it may touch based on the brands 60,000 the minimum.
you mean less than 1 lakh?
Yeah. Those days are over. I mean, they used to quote 1 lakh for 1 kilowatt those days. Now, if you make, I mean, as being an engineer or a scientist by nature, you all can do it yourself. If I can do, you can do. So 1 kilowatt power, if you have already done the what you call favorable wiring at your home. So this is it.
Yes, sir.
60 to 70,000 rupees, you can have 1 kilowatt solar power off grid at your home. You consider 70,000 rupees, which will produce kind of minimum average 3 to 4, sometimes 5. In summer, you can get 5 units.
Yes, sir.
In other times, rain, it can come down to 2 units per day.
Yes, thank you, sir. I think many of us can try to install the solar panels.
Yes, sir. So why I took this up is to instill an interest in the young minds, as Professor told in the beginning. First of all, as academicians and the students and engineers, a lot of guys can take up automating this whole thing. I just oversimplified. There are
Yes,
possibilities
sir.
like
Yes, sir.
the solar panel tracking the sun for maximum, then it will produce double. As the sun moves, you need to track so that the incidental light will be always perpendicular to the surface. So it can produce, instead of 5, it can produce 10. So we can automate that. You can use a microcontroller, you can use a stepper motor, and you can use a GPS, you can use a software to track the sun. So there are a lot of possibilities for projects in solar power. It is a marriage, it's a happy marriage between power electronics and computer science and electronics. So huge possibilities are there. And also, if you don't want to take up this as a project, I encourage you all to go and convince your parents. I'm talking to students and others. Convince your people to do this thing at least a 1 kilowatt at your home, so that you are carbon neutral. You have gone. It's a green act, and you are not dependent on your power company. You are not at their mercy, especially when you are working from home, especially when you are learning online classes at home. You cannot afford a power interruption. If you already have a small kind of setup inverter, change that into a solar one. So I request all of you today or tomorrow to have a solar power rooftop power plant at your home. That's the idea of my spending my time on this today.
Yes, sir. Yes, sir. Thank you very much, sir.
Yeah, you're welcome, sir.
Hello,
Yep.
Dr. Tom,
Yes, sure.
Dr. Dinesh here.
Yeah, back to you.
One question I have, I think, is that you said two-sided as also one-sided.
Yeah.
If you see, a part of the solar energy only is tapped for producing the electricity. Rest of it will go through.
Yep.
Now, when we have a two-sided one, the heat is trapped inside. Will that not produce a lot of heat and cause heat dissipation problems?
That's a good question, sir. There is a dependency on heat as well. Okay, I mean, I didn't touch upon that. For every single degree increase in heat temperature, there is a fall in production kind of a 0.3%. So that's why I told a lab condition, it is always tested 25. When we have 40 degree, there is a heat kind of what we call trapment inside, but we have to ignore that. But if you can cool it, I mean, and the project idea, I know where you're coming from. If you can handle the heat dissipation, that will increase the efficiency.
Okay. A corrected one. One more side question is that, have there been any efforts worldwide and by yourself to use mirrors in conjunction with the solar panels to maximize the collection of solar light?
Yeah, good question, sir. I also tried here. I mean, my friend is also here in this. I said my colleague Sahadev, and I tried. We can use the heliostat. You see, by the movement of sun, if you want to focus the light beam, reflected light onto certain surface, you need to track the mirror. Otherwise, after a few minutes, mirror is off track because sun moved. So you can have a tracking continuously on one place, one surface, up or down, wherever. It will generate more power, of course. And the thing is that why it is not done commercially, the tracking mechanism is expensive and maintenance is expensive. You need to clean both the solar panel as well as the mirror. And if the sun goes down due to cloud, both will not work. So because of the additional cost, people have gone for simplified production, but I was interested, I did this thing, and it's not conducive for a rooftop mounted solar power plant to have a heliostat. But if you have a space constraint, and sir, if you can develop a small system affordable for Indian households, people can put this into place, and with just one bifacial solar panel, we can have double. Nowadays, the power has gone up to even 500 watts per one side. So in theory, if you eliminate the upside, the sunny side by sun, and below it by reflected light, it can give one panel can give 1 kilowatt in theory. Back to you, sir.
Yeah, what I'm also thinking is not just making the mirror to move, because that will be movement and all that will be more complicated. Static mirrors, several of them mounted in such a way that each one will focus the light of the sun on one spot at different points of time. Because mirrors are cheap.
Yep.
So one will now focus it between 9 to 10. Another will focus between 10 to 11. Like that, if you have about 8 mirrors, mirror arrangements, which are always fixed, but they will all focus it on the solar panel only. Thank you.
That's a wonderful idea, sir. That's a wonderful idea. As you said, the mirror is very cheap. It's a wonderful idea. You could think about it as giving us a project and a research project. It will be wonderful.
Yeah. Thank you. Thank you.
Thanks for that suggestion, sir.
Any questions from audience? Any other questions from participants?
Hello. Good evening.
Hello, ma'am. So my name is Akshay. I'm from electrical department. So whatever Dinesh sir asked a question that can the mirrors be placed in a static way and they can be placed such a way that at different times of time they can reflect on this work. I think not studied. I'm into this solar energy from last year. I'm searching about this. I wanted to place it for my. I planned it for my home. So while searching, even I had this plan and I googled through that. It was searched very long back ago that if we do such things, the whatever the flights will be going on, they will be harmed because the sun direction will be changing from morning to evening. So the reflection can go away from the solar panels and it can affect the flights going through. They can get the reflection and there might be some problem or something. So because of this idea was removed.
Yeah, Shay, that's a valid point because aviation is very important, especially in a place called Bangalore, but that can be handled. That's why students like you should come up with novel ideas, like you can disable that mirror when, as sir said, 9 to 10 one mirror, 10 to 11 another mirror. The previous mirror, which is expired in time, can fold off, because you can use cheap simple actuators to fold it off so that it won't reflect anymore. That's why the scope for research. You guys should have if you have good interest in this thing, you can take it up. How can we avoid this dangerous thing due to which some other companies drop that idea, but we can take it up. The mirror can be folded.
Dr. Tom, not only the folding, instead of folding also, we could use glass panels which will only allow light to go one way. So the reflected light of mirror in any other direction will not go because of the one-way see-through glass panels.
Yeah.
There's also a possibility.
Yeah. Sir, I mean, you are all in the wonderful world of research continuously. So for you all to do this thing and propose this thing very easy. If you remember, we used to have LCD projectors long ago. What do you call projectors? So there's no LCD in it. There is a matrix of micro mirrors, and they reflect the light. The RGB panel, elements are mirrors. So in a field of matrix of micro mirrors, we achieve image projection. So it is already there. So micro manipulators can do this. And you can, as you said, it's an experiment in optics. You can have selective reflectance. You can have a lot of things. So research is unending. So, sir, I mean, it is your duty to instill interest in your students and get these things done. So that your department and your students will get the credit for it. I can collaborate with you.
Hello.
Yep.
If I have time, can I ask one more question, sir?
Yeah, sure. I have time. It's up to you guys how much more. I have time. Please go ahead.
Yeah. So what we discussed about is the semiconductor gate silicon, right? Nowadays, they are talking about organic solar cells. How about the efficiency of that compared to this, and how that work is going on, sir?
That's a good question. There are different applications, as I said. Very rugged thing wherein it is facing sun all the time, rain comes, dust comes, lot of things. So it has to be very rugged. So at the same time, it has to produce a lot of power because it's huge, because this is all power electronics. The organic solar panels, they have an inherent problem of longevity. These normal solar panels are all rated for 30 years. And the guarantee is that 80% of the power generation is guaranteed for 20 or 25 years. Whereas the organic solar power, it's a different approach. Okay, it's not The normal one, they're flexible, they are light, they're sensitive, but their power output is very less. Cost is very high. And of course, they're light and their output is very less. Is very less. So for normal applications where price is a big consideration, you cannot use this. But for specific special applications, they are using organic, and its efficiency is also slowly coming to the silicon-based solar panels, maybe in few years. But cost is a problem. So for, say, you see this satellites where there is no problem for money because they can spend millions. So where there is no constraint of the money, they are using this kind of high cost, low weight kind of a solar panels. There's something called perovskites. For information, you can search perovskites. It's competing with the silicon for that space. In few years, solar cells may not be this thing. It could be novel things like perovskite crystal structure. So thanks for reminding us on this thing. I'm sure others will also read upon this.
Yes, thank you, sir. Thank you, sir.
Good evening, sir. Sir, my question is, can we have monocrystalline PV cells for residential use? If so, compared to polycrystalline, what's the difference in cost and efficiency? So,
That's a good question. So I'll show you my setup, my humble setup here. Yeah, this is my first experiment. This panel you see here is monocrystalline PERC type, PERC. This versus polycrystalline, which is my neighbors are using. They were using it. It is very cheap. So a comparable size will not give you in polycrystalline the same output. Mine is 375 watts. So equivalent size, physical size of a polycrystalline will give you 250, or in today's poly PERC may give 300. But it is cheaper. When I paid this for 12,000, I bought it at that time, equivalent 1,000. And longevity is kind of same. All are guaranteed for 25 to 30 years. And this is a difference. Mono PERC is sensitive and higher efficiency, but costlier. When it is 12,000, now this panel you may get for 10 or 10.5K. Equivalent polycrystalline will be only, say, 8,000 rupees. So this is a difference. Poly is cheaper, but less sensitive, less efficient. And mono is costlier, but it is highly, efficient. Pardon?
costlier, but output is, the performance is better. And coming to the, yeah, and coming to thin film technology, sir, they have a major applications in rooftop PV panels. So how is it commercially, sir? Can people go for thin film technology?
I wouldn't suggest right now because thin film fabrication is not massive. Okay, it is done by sputtering, vacuum sputtering, and all those technologies. So you cannot have that produced massively. So it cannot cater to the market's huge demand. Because of that sensitive nature of its manufacturing, it is expensive. And as I said, people expect this to work for long years. Thin film, being it's very fragile, it will not give you that longevity. So efficiency is thin film is again less, and it is costly, longevity and availability. And while mono PERC and the dual cut cell, Eclipse, and a lot of these things are still being improved. So in Europe and China, a lot of R&D is being happening. So you see, the commercial production is a different animal. While you have a lot of perovskite, you have unijunction transistor-based kind of technology for higher efficiency. All these things are still in lab. Like mono PERC came out of lab in the recent years. These, as you said, will come out one day. But right now, they're all expensive.
Okay, sir. Thanks a lot, sir, for this information.
Hello, sir. Shankar from electrical department. I came through a conspiracy that so extensive use of solar panels will lead to global warming in coming years. What is it true, sir?
I don't believe, because you see, for anything there are debates. When Tesla car comes to replacing of fossil fuels, there is a debate. When solar power comes, there's a debate. But if you look at the positive side of it, a solar power is generating free energy without smoke, without emission. So some people say this glass is reflecting some of the energy back to the atmosphere. Even if it is not glass, it will be still reflected. And when you consider small, so for argument's sake, a lot of people are arguing that this will no. You see, when in an NTPC generator somewhere in India, when they generate 1 kilowatt, there's an equivalent amount of carbon released to the environment. Wherein in solar power, I am proudly saying right now, today I might have, my panels might have produced, all 4 panels together might have produced a kind of 6 or 7 units, 0 emission. Then you decide. So the most favored green power generation method now available to human being is solar power, using solar panels. It is established, and all countries are forcing people. Now in 5 years from now, I mean, we are all in Bangalore, BBMP will mandate like a solar water water heater. It is mandated. If you are making a new independent house, to get the license or approval, you need to have a solar water heater. Like that, solar power plant will be mandated in future soon. So how are they doing it? They're not fools. There are convincing evidence that this is not. While producing a solar panel, of course, we did some pollution, but that is one time. It doesn't pollute every day like a car does, like a power plant does. I mean, a thermal power plant does. So obviously, this is a green way of producing electricity. Shankar, did I answer a
Yeah, sir.
question?
So I think no more questions from the participant side. So we can end this.
Please read up. Don't believe me. Read up. A lot of information are available. Yeah, sorry, ma'am. I took a lot of time. If there is any more question, you can reach out to. Yeah, please.
Anyone?
The last question.
Participants have any questions?
Yeah, Rajkumar, you can go ahead. Maybe this is the last question, ma'am. We will finish with this. Please go ahead, Rajkumar.
Yeah, okay, sir.
Yes. What is instead of using the tubular battery between the normal batteries for solar power storing the energy? What is the difference between that both batteries capacities? Are there have a long life?
I'll explain. The tubular batteries are made for inverters, for quick charging, and similarly quick discharging when you need power. Okay, so tubular is a recent development, maybe last 10 or 20 years, and the earlier ones were flat plate batteries. So tubular is optimized for variation in charging current. Okay, an ideal, normally a battery will need at least 15 amperes at 12 volts or 12 plus 12 is a nominal voltage for getting charged up. And as you charge from bulk to absorption to float, it will go up. At that time, normal batteries will not sustain that. And all these optimizations are for a longer period of life. If you misuse, it's not that simple as you see it. If you charge it, if you don't charge it properly, its future will be affected. Instead of 10 years or 7 years based on the usage, you will get only 3 years or 4 years, and it will die. So tubular is optimized for inverter purpose. Tall tubular solar batteries are optimized for solar use, wherein you have erratic power coming, but demand side is constant, and you need a quick charging. So that's the difference.
So thank you, sir. Thank you.
Thank you for such a wonderful session it was, sir. It was packed with a lot of information. Your session was well received. I would like to thank you for such an interesting session. And I would like to thank each and every participant for being with us. Thanks a lot.
My pleasure, ma'am, to have spent time. Thanks. Thanks for everybody for joining, and I extend my thanks to RNSIT and the EC department and Dr. Dinesh and others for listening carefully and asking questions. It was a live audience. Thanks a lot. Good night. Take care.
Thank you, Dr. George. Have a good evening.
Thank you, sir.
Thank you. Hello, Gausia madam. Are you there? Hello.
Yes, sir. Yes, sir. I'm here.
Yeah. It was a nice talk. I think majority were second semester students.
Sir. Many are there.
Okay. By chance, if it is possible, is it possible to share the slides what you have showed?
So I've recorded. Can I share the video with you, sir?
Yeah, please, because in the first and second semester we have that solar panels, PV cells.
Okay.
So we can share it to the students in the coming days.
Okay, sir. I will share the video with you, sir.
Okay, madam. Thank you.
Thank
Good night.
you. Good night, sir.